Hello everyone. So we're going to continue now our discussion. Uh, so this is the slide that we ended up. No? So we now proceed with module 2, okay, concerning fluid statics. No? So when we talk about fluid statics, this is a branch of fluid mechanics that studies incompressible fluids at rest. It concerns with the study of pressures throughout the fluid at rest and the force on finite surfaces. Okay, so this is all about fluid statics, no? Okay, so it is a branch of fluid mechanics, no? That studies incompressible fluids. Take note, incompressible. Okay, so meaning liquid is assumed to be incompressible. Okay, so in our discussion concerning this module, all fluids will be treated as incompressible. Okay, so that studies incompressible fluids at rest. Okay, so meaning as you see in this illustration, we have this figure, we have an aquarium, and as you notice, the fluid is at rest. Okay, so incompressible fluids at rest. Okay, so there's no, so it is somewhat stagnant, no? Okay, now it concerns with the study of pressures throughout the fluid at rest. Okay, so it concerns study of pressures. So there is pressure inside this liquid, as you notice. Okay, and the intensity of pressure, no, varies. With varies with respect to the elevation. No, okay. So we'll talk about in detail that topic, no, when we reach pressure in a liquid, no. So study of pressures throughout the fluid at rest, no, and the force on finite surfaces. So as you notice here in this aquarium, we have finite surfaces. Okay, the aquarium supports water inside. Okay, there is force exerted by water, no, on the aquarium. No, there is a force exerted, no, by this fluid, no, in this aquarium. Okay, kung hindi kaya ng aquarium na i-handle yung pressure sa loob, okay, mababasag siya, no? Mababasag itong aquarium. Okay? All right. So application nito, if you have, so sa mga dam, okay? Sa dam application yan. Okay? So kapag ka umuulan, nag-iimbak ng tubig sa dam. Okay? At yun na imbak na tubig na yon ay at rest. Okay? Kaya kung nababalitaan nyo, yung nagpapakawala ng tubig sa dam kapag ka mataas na yung level sa isang hydroelectric power plant. No? Okay? So, let us now proceed with in detail. No? So, we start with pressure. No? So, when we talk about pressure, this is the normal force per unit area. No? So, in this case, we have the formula P equals F over A. No? Okay? So, F here is the normal force. When we talk about normal force, the force is perpendicular to the area. No, the force is perpendicular to the area. Okay? So F is perpendicular to A. No? And the units are as follows. No? For pressure, it can be expressed in PSI, in kilogram per square centimeter, atmosphere, Pascal, millimeters mercury, inches mercury. So take note, no? Kilogram force, okay? So I will indicate a unit. It's kgf, okay? Meaning that kilogram is used as a force. Take note that kilogram can be a mass, can also be a force, okay? All right, so in this case, it can be expressed in psi, no? Kilogram force per square centimeter, atmosphere, Pascal, millimeters mercury, or inches mercury. Okay? So the pressure, no? So we have here the force, okay, and this is the area wherein it is 90 degrees, no? The angle between F and A is 90 degrees, no? So so to measure pressure, similar to stress, it's F over A, no? So it's F over A. And note that for every atmosphere, 1 atm, that is equals to 14.7 psi. No? So 1 atm is also equal to 760 millimeters of mercury, which is also equal to 29.92 inches mercury. Okay? So yun yun. So kapag ka nag-solve tayo ng problem regarding this topic, no? So gagamitin natin yung iba dito, no? So we have here Pascal's law, or also known as Pascal's principle. So Pascal's law, developed by the French mathematician Blaise Pascal, states that a change in pressure applied to an enclosed fluid is transmitted undiminished to all portions of the fluid and to the walls of its container. Okay? Ulitin ko, Pascal's law, dinevelop yan ni Blaise Pascal, stating that a change in pressure. Pagka raw may pagbabago sa pressure, apply to an enclosed fluid. So in this case, we have an external pressure. So nag-apply siya ng force, nagkaroon ng pressure sa loob. Okay? So external force, okay? And with that external force, no, there is now change, there will be change in pressure inside, no? Magbabago yung pressure sa loob, no? A change in pressure applied to an enclosed fluid, no? So we have here a certain object with fluid, okay, inside it, and a force is applied to that object, okay, and the pressure now will change inside, no? Kasi may tendency na puputok 'yan pag hindi nakayanan ng material yung change in pressure, no? So dapat kayanin niya para hindi pumutok. Okay? States that the change in pressure applied to an enclosed fluid is transmitted undiminished to all portions of the fluid. Okay? Ibig sabihin niyan, natatransmit daw, no, to all portions in the fluid and to the walls of its container. yung change in pressure. Okay? It is transmitted and diminished. Okay, ibig sabihin niya, walang pagkabawas. Okay? Pagka nagkaroon ng change in pressure sa loob, okay, yung change in pressure, lahat ng molecules sa loob ng ano na to, material na to, yung fluid na nandyan, magbabago yung pressure. Okay? Same amount, no? So, it is transmitted, undiminished. Sabihin, walang, hindi nabawasan yung value ng change in pressure hanggang sa makarating sa wall ng container na to. Okay? So, nagkaroon ngayon ng change in pressure sa wall ng container na to. No? So, yung change in pressure, initial, okay, pagdating sa container, ganun pa rin. Yung change in pressure, hindi na bawas. No? Hindi na bawas. So, dapat kayanin ng material para hindi siya pumutok. Yung change in pressure na yon. So, natatransmit siya. So, nagkaroon ng, nag-exert ng force. So, we consider that as external pressure. Okay? Nag-exert siya ng force. Itong tao na to. So, ngayon, may kaakibat yun na pressure. At magbabago yung pressure sa loob ng material. Okay? At yung pagbabago na yon, okay, affected lahat ng molecules, no? So natatransmit, no? So natatransmit 'yon hanggang makarating sa material na to, no? Sa wall ng material na ito. Okay? So in that case, uniform 'yan, no? So in all directions. Okay? In all directions. Okay? So uniform pressure. So ganun no, Pascal's law, no? A change in pressure applied to an enclosed fluid is transmitted undiminished to all portions of the fluid and to the walls of its container. Okay, ganyan yung Pascal's law or Pascal's principle, no? So, pressure applied on one point of liquid transmits equally in all directions. Okay? So, pressure applied on one point of liquid, no? So, yung pressure na yan, may kaakibat na force. Okay? On one point of a liquid transmits equally, no? In all directions. So, natatransmit, no? Naipapasa. Okay? Yung pagbabago sa pressure ng isang molecule ng liquid sa loob, naipapasa sa lahat. Okay? And it is transmitted equally in all direction hanggang sa wall ng container. Okay? So, ito yung isang application ng natin ng Pascal's law. Okay? Sasabihin niyan, ito ay mabigat. Mabigat to, ay hindi. Ito ay magaan lang kumpara dito sa pangalawang object, no? Yung piston. Okay? Consider this piston. This piston has a smaller mass compared to this piston with a greater mass. Ibig sabihin yan, pagka smaller yung mass nito, greater yung mass nun, okay, mas madaling mag-exert ng force sa maliit na mass kumpara sa malaking mass. Okay? So, ibig sabihin yan, no? Regardless kung itong mass na to ay malaki yung mass or maliit yung mass, pag nagkaroon ng change in pressure, no, sa loob dito, okay, yung liquid, kasi nag-exert siya ng force. Yung force na yan, may corresponding pressure. Okay? So, yung pressure na yan, okay, matatransmit sa liquid na to sa between the two pistons, no? So, matatransmit yan. So, magkakaroon ng change in pressure dito sa ilalim. Okay? So, dahil sa nagkaroon ng nag-increase yung pressure, okay? Ang tendency, may iaakyat yan, yung piston na yan, with the same amount of pressure. No? Kasi kung gaano kalaki yung amount ng pressure, increase, okay, ganun din yung may apply dito sa piston hanggang sa wall ng piston na to. Okay? Hanggang sa magmo-move yung piston na malaki. Okay? Magmo-move yung piston na malaki corresponding to a force F2. Okay? Dahil sa change in pressure. Okay? So, ganun siya. Alright, so we can proceed. So, let's study now atmospheric pressure. No? So, when we talk about atmospheric pressure, it is the pressure at any point on the Earth's surface from the weight of the air above. No? Okay. And it is also known as barometric pressure. Okay? So, I think naaral nyo naman to sa thermodynamics, right? So, pag sinabi nating atmospheric pressure, pressure at any point on the Earth's surface from the weight of the air above. Okay. Okay, on planet Earth, meron tayong atmosphere. Yung atmosphere, meron tayong air. No? Ngayon, ang air na yan, surrounding our planet, has a certain weight. No? That is distributed uniformly sa ating planet. No? That is the assumption. It is distributed uniformly. No? Now, we consider now, so this is planet Earth, for example. So this is the atmosphere. Now, with the presence of air, no? So, halimbawa, meron ako ditong surface, no? So, meron ako ditong surface. Okay? Let's say, ito ay aking table. Okay? So, meron table. Okay? Ngayon, mayroong air. Okay? So, yung air na yan, nag-exert yan ng force. Okay? Dito sa table na yan, yung air. Okay? Ngayon, yung air na yan na nag-exert ng force dito sa table, sa area na to, okay? So, there's that force, no, is converted to pressure. No? So, yung pressure na yon, tawag natin dyan is atmospheric pressure. Okay? That is pressure, no, at any point on the Earth's surface. Okay? At any point on the Earth's surface, including object, no? So, kung ito yung ground, okay? So, surface, Earth's surface yan, okay? So, meron tayong air at nag-exert yan ng force dito sa ground. Meron kasing bigat yung hangin eh. Okay? Nag-exert ng force yan. Okay? So, from the weight of the air above, because of the weight of the air, yun ang rason. No? Alright, so we continue. So atmospheric pressure is also known as barometric pressure. Okay? And a barometer measures atmospheric pressure. Okay? So barometer is the instrument that we use in measuring atmospheric pressure. And this is an example of a barometer, a mercury barometer in particular. Okay? So there is atmospheric pressure, no? There is force exerted on this on mercury, no? Force exerted on mercury, no? Due to air, no? Due to air. And with that, so there is a rise in mercury inside this tube. Okay? Wherein this part is vacuum. So later I will discuss vacuum. No. So when we talk about vacuum, to give you an idea, it has something to do with the absence of molecules in a certain region of space. No, it has something to do with the absence of molecules. Okay, in a certain region of space. No, so under normal conditions at sea level, no, so at sea level, no, so kung yan ay sea, so at sea level, okay, so meron tayong atmospheric pressure ngayon. At yung atmospheric pressure na yan, okay, 1 atmosphere. Kino-consider natin siyang 1 atm. 1 atmosphere. At yung 1 atmosphere na yon ay 14.7 pounds per square inch. Yung kanyang equivalent. 14.7 psi. Okay? Or 101,325 pascals. Or 760 millimeters of mercury. No? So, ganun siya. Or 29.92 inches of mercury. Okay? So, take note that the atmospheric pressure in terms of height ng mercury. So, kino-consider natin itong pressure, no? Yung height ng mercury, itong height ng mercury na yan, kino-consider nating pressure yan. Okay? So, or in terms of inches of mercury, 29.92 inches. Okay? So, it can be interpreted as height, or it can also be interpreted as pressure, no? Itong 760 millimeters mercury or 29.92 inches of mercury. Now, let's talk about vacuum in detail. So, vacuum is a space in which the pressure is considerably lower than atmospheric pressure. Anong dahilan nun? Bakit considerably lower than atmospheric pressure? Ibig sabihin niya, nagkukulangan ng molecules sa loob ng space kumpara sa atmospheric pressure na sakto. Sakto yung mga molecules, no? Yung amount of matter na nasa atmosphere ay kinukumpara natin sa amount of matter na sa isang space, na enclosed space, na kung saan yung amount of matter doon sa atmosphere ay hindi katulad ng amount of matter na nasa space na to, no? So, pag considerably lower, no, the pressure is considerably lower, sabihin niyan, yung amount of matter sa space na to ay mas konti, no? Kumpara sa atmosphere, kumpara sa molecules, or should I say kumpara sa matter na nasa atmosphere, no? Okay. So in this case, vacuum pressure is less than atmospheric pressure. Okay? So dahil konti yung mga molecules, konti yung mga, so sa space na to, okay, less matter, okay, outside, okay, enough matter, okay. So pagka less matter, pag sinabi nating matter, matter is anything that occupies space and has mass. Diba? So pag sinabi nating matter, pwedeng we're referring here to gaseous substances. No? We're referring to gaseous substances. No? So it can be liquid, it can be gas, it can be solid, but since our subject is fluid mechanics, okay, our assumption here is that matter here is considered as gas. No? So, sabihin niyan, yung particles ng gas sa loob ng vacuum, sa loob ng space na to, ay mas konti kumpara sa particles na nasa labas. So, kapag mas konti yung particle, nagkakaroon ng pressure na mababa kumpara sa labas, kumpara sa atmosphere, no? Kumpara sa atmosphere. Okay? So, pag ganon, ang kino-consider natin na vacuum, no? Yung space na yan. Pag less matter, kumpara sa atmosphere natin. Sa Earth's atmosphere, kumpara sa Earth's atmosphere. Okay? Kino-consider natin siyang vacuum. So, is a space in which the pressure is considerably lower, okay, than atmospheric pressure. Okay? So, if considerable amount of matter is removed in a region of space, such region of space is considered vacuum. No? So, there is considerable amount of matter removed in a region of space, diba? So, sabihin niyan, less matter. Okay, enough matter sa labas. So, kino-consider nating vacuum yung nasa loob niyan ng space na yan. Okay? Now, if all matter is removed in a region of space, such region of space is considered perfect vacuum. So, pagka no matter sa loob ng space na yan, okay, kumpara natin sa atmosphere ng Earth, okay, kumpara sa atmosphere ng Earth, no? The Earth's atmosphere, pag ganyan yung sitwasyon, kino-consider natin tong perfect vacuum. Okay, perfect vacuum, no? So let's now proceed with gauge pressure, no? So gauge pressure is pressure relative to atmospheric pressure. Okay? So sabihin niyan, ito yung reference natin, atmospheric pressure. It is pressure relative to atmospheric pressure. So in other words, kung ito yung atmospheric pressure natin, kino-consider natin tong gauge pressure equals 0. No? Kino-consider natin yan, gauge pressure equals 0. So tapos, Pag yung gauge pressure positive, sabihin higher than atmospheric pressure. Pag gauge pressure mo negative, below atmospheric pressure, sabihin niyan vacuum, no? Sabihin niyan less matter, no? Less amount of matter dun sa space na yon kumpara sa Earth's atmosphere. Pag naman gauge pressure positive, okay, more amount of matter sa isang space kumpara sa atmosphere, no, ng Earth. Okay, more amount of matter kumpara sa atmosphere ng Earth. Okay? So, we can proceed. So, bigyan ko yung halimbawa, no? So, kung meron kang balloon, yan, balloon, ipan natin. Pag inipan mo, malalagyan ng hangin. Lagyan mo pa ng hangin hanggang lalaki ng lalaki. Tapos, so yung space na yan. Okay? So, meron ngayong pressure. Okay? Okay, nagkakaroon ng pressure. So, ibig sabihin yan, so there is, kumpara sa natin sa Earth's atmosphere, no? Okay, hinipan mo ng hangin. Mas maraming amount of matter dito. Okay? Kumpara sa Earth's atmosphere. Marami kang nilagay eh. So, sabihin niyan, we are expecting gauge pressure to be positive. No? We are expecting gauge pressure to be positive. No? Because there is more amount of matter inside this space. No? Inside this object in compare with the Earth's atmosphere. No? So some instruments in measuring gauge pressure are manometer and Bourdon gauge. No? Okay? Named after the French inventor Eugene Bourdon. No? Okay. So ito yung ating measuring instrument. No? Okay? So kumpara natin, so analyze natin some instruments in measuring gauge pressure are manometer. So this is manometer, no? And this is the Bourdon gauge, no? So yan yung ating Bourdon gauge. So yan yung mga instruments in measuring gauge pressure, no? Okay. So let's go back yung sa aking discussion. So inipan natin yung balloon. Okay? Nabigyan ng hangin. I-compare mo na ganyang size, no? Pero hindi mo hinipan. Ibig sabihin, free to ano lang, yung hangin na pumunta diyan. Hindi mo hinipan. Free to occupy itong space na nasa loob ng balloon. So same volume, pero mas maraming matter na nandito kumpara dito na hangin lang yung nagsusupply. No? Hangin lang yung nagsusupply eh. Okay? Hangin na nagmumula sa ating atmosphere. Okay? Same amount of volume. So ito kasi kontrolado mo, hinihipan mo ng hangin. Okay? Ito, hindi niya hinihipan, same lang. Okay? Same lang. So, ibig sabihin niya, dahil mas maraming matter dyan, no? So, tendency, we are expecting na positive yung ating measurement ng pressure. Okay? So, positive. Sabihin yan, above atmospheric pressure. Okay? So, let's now go to absolute pressure. So, absolute pressure is the sum of gauge pressure and atmospheric pressure. Ganun kasimple. So, meron tayong gauge, meron tayong atmospheric. Absolute pressure is simply the sum. Gauge plus atmospheric. And absolute pressure is the pressure above absolute zero, and we call that absolute zero as perfect vacuum. No? So this is the formula I have introduced before, that the absolute pressure is the sum of the gauge pressure and the atmospheric pressure. And absolute pressure is the pressure above absolute zero. Okay? That is perfect vacuum. So in other words, ito siya. Ito yung perfect vacuum. Zero yung absolute pressure. Okay? Zero absolute pressure. Okay? So sabihin niyan, kung ito yung kanina, atmospheric pressure, ano? Negative. Sabihin niyan, gauge. Negative nung gauge pressure. Sabihin niyan, vacuum na yan. Vacuum. So, pag yung absolute pressure naging zero, sabihin niyan, under perfect vacuum. Sabihin, no amount of matter in that region of space. No? No amount of matter in that region of space. So, sabihin, wala, as in wala, walang matter sa loob ng space na to. Okay? Inalisan ng matter. Okay. So that is considered perfect vacuum, and that will correspond to a zero absolute pressure. Okay? So we have now here pressure variation in a liquid. So let's study this in detail now. So there is variation in pressure in a liquid now. So consider an object inside this liquid. Okay? And in that case, let's say this is the cross-section area of this object inside this liquid. No? Okay? The object is submerged. No? The object is submerged in a body of liquid. Okay, nakalubog siya. And this is now the height. No? So we have the cross-section area of this object and the height of this object. And we consider the center. No? And at the center, there is weight. No? There is weight of the object. Now, there are other forces acting on this object aside from the weight of the object. No? Other forces is that since there are molecules of water on top of this area, okay, there are molecules of water on top of this area, that will correspond to a force. No? So, may bigat yan eh. So, yung mga molecules sa taas niyan, may bigat. So, therefore, nag-exert yan ng force. Okay? Dito sa area na yan that we will call F1. And then, also, at the bottom, okay? At the bottom, meron tayong body, meron din tayong liquid, syempre. Okay? So, kinokontra naman yan. Kinokontra niya yung weight at saka yung force na nasa taas. Okay? So, nagkokontrahan niya. So, there is also a force exerted, no? By the liquid down, no? Downward. So, upward direction, no? That resists the force above and the weight, no? So, we can now sum up forces vertical, No? So these are all the forces acting on the object. And applying Newton's first law of motion. Okay? Applying Newton's first law of motion, we can able to equate the sum of all forces vertical equals zero. No? The sum of all forces vertical equals zero. So that is for Newton's first law of motion, the application of it. Applying Newton's first law, we can say that summation of forces vertical is zero. Because Newton's first law of motion has something to do with a body in equilibrium, right? Body in equilibrium. And there are two conditions for equilibrium of the body. Okay? If the body is at rest, or if the body is at constant velocity, it is considered in equilibrium. If the body is at rest, it is considered in equilibrium. If the body is at constant velocity, it is also considered in equilibrium. So if it is in equilibrium, no, the sum of all forces acting on the body is zero. Okay? So our reference is Newton's first law of motion. That's why we sum up all forces vertical equals zero. So knowing that, so considering upward forces as positive, downward forces as negative, no? So we have F2 going up. Since F1 is going down, we put minus F1. W going down, minus W. So then we equate to zero. So recall that the pressure is equal to force over area, and the force is simply the product of the pressure and the area. So there is pressure at this area because there is force. With the presence of force and the area, okay, there will now be pressure in this area, okay, due to water, no? And F now is equals to PA. Similarly, there is area here, same as this. There will also be pressure downward, okay? Pressure at the bottom of this object. Recall also that the weight is equals to the product of the mass and acceleration due to gravity. Okay? And with that, we have now P2A2 minus P1A1 minus mg equals to 0. Recall also that the density of the object is equals to mass over volume. No? The density of the object is equals to mass over volume. Okay? And with that, the mass of this object can be obtained by multiplying the density and the volume of it. That's why we have now this formula, m becomes rho v. Uh, and also the volume is simply the product of the area and the altitude. No? The product of the area and the height of the material, of the cylindrical material. No? A times h. No? So that's the volume of the container. No? So we have now V is now equal to AH, and this will be our formula. And note that A1 is equals to A2 is equals to A. No? So the area at the top of the container is at the same as the area at the bottom, which is equals to A. No? And then we can now replace A2 and A1 by A. Okay? And we divide both sides by A, and A will now be removed because A is a constant. So this is the simplification of this equation above. So P2 minus P1 is equals to rho GH. So we have transpose rho GH to the right, no? So the sign of it will change to positive. So P2 minus P1 is change in pressure, no? So pressure at 2, pressure at 1. So if we subtract that, that is rho GH. And take note that the specific weight, no, is equals to, I have already introduced this before, the product of the density and acceleration due to gravity. No? The specific weight of the fluid is equals to the product of the density of the fluid and acceleration due to gravity. That's why it becomes gamma, not the Greek letter gamma. Or we can able to transpose P1 to the right side. We have now P2 equals P1 plus gamma H. No? So take note that pressures along the same horizontal plane in a homogeneous fluid at rest are equal. No? Pressures along the same horizontal plane in a homogeneous fluid at rest are equal. So in other words, so the pressure, no, at this level, no, the pressure at this level, which is horizontal, are all the same. No, pressures, the pressures at this level, no, are all the same. Pressures along the same horizontal plane in a homogeneous fluid at rest are all equal. No, and then take note that this is the free liquid surface. The free liquid surface. Okay, so it is the we have here the interface of liquid and air. The interface of liquid and air. So in that interface, that is now the free liquid surface. Now we consider that to be the free liquid surface. Take note that the gauge pressure at the free liquid surface is equal to 0. Okay, this is air. And at the interface of the liquid and the air, no, the gauge pressure is considered 0. No, the gauge pressure is considered 0. Okay, right? Because the atmospheric pressure, the standard is 1 atm, and the corresponding gauge pressure measurement for 1 atm is 0 gauge. No? So 0 gauge pressure. So let's answer a problem with regard to this topic. What is the pressure in kPa at the depth of 4 kilometers below the ocean? The specific weight of the ocean water is 10.05 kilonewton per cubic meter under ordinary conditions. No? So required the pressure in kilopascal. So we have the given figure. No? So we are to determine the pressure. No? in kPa at a depth of 4 kilometers. At a depth of 4 kilometers below the ocean. The specific weight, so what is that pressure? The specific weight of the ocean water is 10.05 kilonewton per cubic meter. Okay, under ordinary conditions. Now, solution. So, P2 equals to P1 plus gamma H. No? This was derived in my previous slide. No? The pressure, no? The pressure at the bottom is equals to the pressure at the top plus the product of the specific weight of the liquid and the altitude. Okay? The altitude is. Okay? And this is our free liquid surface. Okay? Which is the interface of liquid and air. Okay? So the pressure at this part, no, at this point, so that is P, no? So it is equals to the pressure at the top, FLS, plus the unit weight of ocean water multiplied by H, which is the height, no? 4 kilometers below the ocean. So recall that the gauge measurement for the pressure at the free liquid surface is 0. Take note of that. So therefore, the equation will now be reduced, no, to P equals to unit weight, so this is 0. So unit weight of ocean water times the height, no. So, and then we have here, so the pressure is equals to 10.05 kilonewton per cubic meter. Okay, we have that. And height of 4 kilometers, that is 4,000 meters. And our answer is 40,200 kilopascal. Okay? So, kilonewton per square meter, that is kilopascal. So, that is our answer. Alright? So, we proceed. Number 2. Find the absolute pressure in PSI at the depth 20 feet below the free surface of a body of water when the barometer reads 29.90 inches of mercury. The specific gravity of mercury under such condition is equal to 13.57. Okay, so we have to determine the absolute pressure in PSI. And given we have a body of liquid, which is water, and we have a 20 feet depth, no? So find the absolute pressure here, no? At a depth of 20 feet below the free surface of a body of water. So this is the free liquid surface when the barometer reads 29.9 inches of mercury. So we are to determine the absolute pressure at this point. So the barometer reads 29.90 inches of mercury. So that is the atmospheric pressure, 29.90 inches of mercury. Okay? So the specific gravity of mercury under such condition is equal to 13.57. Okay? So this is the height of mercury, no? 29.90 inches. Take note that atmospheric pressure of 29.90 inches mercury is also interpreted as the height of mercury, which is 29.90 inches. No? So this is the barometer, and as we see, there is rise in mercury inside this tube. Okay? And the specific gravity of mercury in this problem is 13.57. Okay? Now, solution to the problem. So, P2 equals P1 plus gamma H. So, our target is P abs, no? And we recall this formula, P2 equals P1 plus gamma H, no? And in this case, take note that in this formula, the pressures can be in gauge or they can also be in absolute pressures, no? So in this case, P2, so is what we're looking for, the absolute pressure. So P1, the absolute pressure for the free liquid surface. Okay, because it is absolute, it's not zero, no? The gauge pressure is zero for the free liquid surface. But for the absolute pressure, it's different, no? So, so that is for the absolute pressure, that is 29 point inches mercury, no? So this is the atmospheric pressure measurement, right? Atmospheric pressure measurement. And with that, that is also in absolute form, 29.90 inches mercury. Okay? So unit weight of water at 4 degrees Celsius. So that is 62.4 pounds per cubic foot, no? Then the height of water is 20 feet. So note that the pressure, the absolute pressure, the free liquid surface is also equal to the atmospheric pressure. Okay? So the atmospheric pressure can be calculated using this formula. So the atmospheric pressure is simply the specific weight of mercury, no? So we have the specific weight of mercury and the height of mercury, which is 29.90 inches. Okay? The specific weight of mercury, since we have specific gravity, 13.57, we can identify now the atmospheric pressure. So in this case, since atmospheric pressure is the product of gamma and H, so it follows that the absolute pressure for the in the free liquid surface is also equals to gamma times H. So the pressure absolute, no, at the free liquid surface is now equal to, so recall, no, okay, the specific gravity is unit weight of the substance over unit weight of water at 4 degrees Celsius. So that's why the unit weight of the substance is simply the specific gravity multiplied by the unit weight of water at 4 degrees Celsius. No? Unit weight of water at 4 degrees Celsius. Okay, that's why we have this. Specific gravity of mercury, okay, times unit weight of water at 4 degrees Celsius. That is now the unit weight of mercury. The unit weight of mercury. So if this is mercury, this will be mercury. Okay? So it's like that, no? So we have now specific gravity of mercury, 13.57, unit weight of water at 4 degrees Celsius, that is 62.4 pounds per cubic foot. no? So, pag-aralan nyo yung dati nating lesson. Okay? Huwag nyo kalimutan. So, 62.4 pound per cubic foot. And then, the height of mercury is 29.90 inches. Okay? And then, i-convert natin yan ng, so magkakaroon, dapat consistent tayo sa unit. Okay? So, we have to get an answer of pounds per square inch. And our answer now is 14.65 pounds per square inch. Now, that is the pressure, no, the absolute pressure of the free liquid surface, 14.65 psi. So, paano siya naging psi? We have pound per cubic foot. Ito siya, pound per cubic foot. Multiply natin ng inches. Okay, times, meron kang cube. For every foot, 12 inches. So, kung naka-cube yung isa, cube din natin yung isa. No? So, para makancel to, no? So, 1 cubic foot, para makancel yon. Okay, 12 inches cube, no? 1 cubic foot, pound per cubic foot, inches, okay, 12 inch cube, no? So, 12 inch cube. So, sabihin yan, cubic foot yan, and then, cubic inches yun nandito. Okay? So, magkakaroon ka ngayon, yung inch na yan, mawawala, at saka inch cube, magiging inch squared na lang. So, yung cubic foot, mawawala, at saka yun eh. Okay? So, pound per square inch. Yun yung unit, kaya PSI, pounds per square inch. Okay? Yan yung absolute pressure natin. Anong in-expect natin? Diba 14.7 PSI? Yung atmospheric natin at sea level. No? At sea level yan. Eh, wala tayo, hindi siya, ito yung barometer reading natin eh. Hindi siya at sea level. No? So, with that, so mayroong slight discrepancy, no? So, we should use 14.65 PSI instead of 14.7 PSI, no? Okay? At saka dapat 29.92 inches yan para maging siyang, at saka dapat 13.6 yan para sakto siyang 14.7 PSI. Eh kaya lang, ang given natin ay 29.9 inches mercury, tsaka specific gravity of mercury is 13.57. So, nagresulta ngayon ng 14.65 PSI. So, ito yung gagamitin natin ngayon, 14.65 PSI. Okay? So, with that, so yan, 14.65 PSI. So, the absolute pressure now, no? Dito na tayo, yung absolute pressure now. Okay, pressure, absolute at the free liquid surface. Again, 14.65 PSI. And then, unit weight of water at 4 degrees Celsius, 62.4 pound per cubic foot. The height of water is 20 feet. Ayan. So, kailangan PSI yung ating final answer. No? So, kaya, meron ka ditong PSI plus, meron kang pound per cubic foot, tapos meron kang foot, tapos, di ba, foot tsaka foot squared na lang nun. Kaya, i-multiply natin ng, para mawala yung foot squared maging PSI, multiply natin for every foot, 12 inches squared, no? So, foot squared, 12 inches squared. 1 foot is 12 inches. So, kaya, mawawala yung, kaya magiging ano na lang, anong magiging unit? So, foot squared, so, denominator inch squared. Okay? So, sabihin niyan, pounds per square inch. PSI plus PSI. So, we'll have a unit of PSI sa ating final answer. No? So, we have 23.32 PSI, and that is our answer. Alright? So, that ends my presentation. Okay? I hope you get it. Good day, everyone.